First, we are going to start the MCP server, which will create an AI service for us using fast MCP. Then we're going to run the MCP client, which uses React and use MCP, a standard hook exposed by MCP library. We see the interface connecting to the service successfully. We need to handle memory ingestion before querying. So we are going to explore the tools exposed by the MCP server. In this case, determine memory architecture. We select it, see the description and inputs. We select a PDF file, in our case, one that has various embedded sections reflecting its hierarchical nature. And then we simply run the tool. In the meantime, let's visualize what the tool does. The user sends the PDF file to the MCP server. The MCP server takes the file and performs a visual inspection. Based on the visual inspection, it can determine tool usage, like text extraction using PDF libraries, OCR if we are dealing with scanned images, or other types of tools. Using these tools, it composes a data representation of the PDF content. With this data representation and LlamaIndex abstractions, it's going to use a reasoning model to propose a memory representation. It will then return this to the MCP client, where the user can inspect it and trigger the storage service. The storage service is powered by a fast API, which takes this data and instantiates the query engines. Together with an LLM, it can then decide which query engine to use. The user can now send a query message. The LLM will choose the appropriate query engine for the given user query. LlamaIndex will extract the chunks, which will help with the question answering. The fast API sends back the response to the client together with the selected memory index and the corresponding chunks. Going back to the user interface, we can see the data representation, including the proposed memory representation. In our case, a semantic index which leverages high-level semantics, and an auto-merging index which makes sense given the hierarchical nature of our document. For simpler documents, this tool will return simpler memory representation. We can also see tool usage, extracted text, and entities. As discussed earlier, we trigger the storage fast API, and then we get the storage configuration where we can see our tools. Now we can query. So we are going to ask a question about data persistence in the database layer. We send the query, and then we're going to receive a response together with the used memory sources and the chunks. We can also inspect the chunks.